All right. So we did mixed number multiplication and division. The next thing is to just do addition and subtraction with mixed numbers. There's kind of two strategies. One option is to just do the same kind of things. So you can just convert to impropers. And go, like, that works. That technically is fine. The downside there is that you tend to get pretty, like, good numbers, like pretty, like, big numbers. So maybe good is not the right word. Good sized numbers, pretty big numbers. It's still manageable, right? I mean, you can always sort of do a little arithmetic off to the side if it comes to it. The other option is, or you can sort of do everything as a mixed number and potentially do a little bit of borrowing or carrying, or sort of stick with mixed numbers and use borrowing and sort of carrying. Potentially. Not necessarily always, but maybe. So we'll do a little bit of a mixture here. Maybe we'll sort of take one or two kind of shorter examples and sort of do them both ways, and then I'll show you some of the carrying stuff. How about we start with something like, again, we'll keep these numbers pretty reasonable. 5 2/3. Let's subtract away 3 and, I don't know. Well, what should we do? Maybe 3 and like 1/8. So, first things first, kind of regardless of what you're doing, you're going to need common denominators, right? So my suggestion here would be convert to a common denominator sort of while these numbers are still a little bit smaller. I would kind of do that as a first step kind of either way. So we need LCD for 3 and 8, right? 3 is a prime, 6, 9, 12, 15, 18, 21, 24 will be our multiples, and 18, 16, 24, there it is, right? 32. What's going to happen here is we're going to just end up doing the values multiplied by each other. So that means we're going to do 8 times 3 and 3 times 8. So this becomes 5 and what? 16 over 24 minus 3 and 3 over 24. So you can kind of start to see a little bit why this is maybe not ideal, honestly, right? Because then if you're starting to do a conversion, you're doing things like 5 times 24, like plus 16. I don't love that. 3 times 24 plus 3. I don't love that either necessarily. Let's just do that so we can sort of see it, and then we'll kind of double back to this and we'll sort of run it without. So 5 times 24 would be what? 120 plus 16 would be like 136 over 24 minus 24 times 3 is 72 plus 3 is 75. So, right, we have these like just wonderful numbers. 136 minus 75 over 24. I'm actually glad we're doing this first because I really don't like doing it this way. I don't love these big numbers. Not that there's anything wrong with them, but like in general, the bigger the numbers get, the just easier it is to make a mistake, I think. So you're just sort of setting yourself up with some sort of booby traps, I feel like, when you run it this way. 136 minus 75. So what's that going to be? Well, 6 minus 5 would be 1. 130 minus 70 would be 60, right? So then this is going to be 61 over 24. Not really going to reduce, right? 61 is a prime. We can just sort of do a quick little conversion. So 24 into 61, that's going to go twice, so back into a mixed number. So that's going to be 2. 24, this would be 48. So we'd have what? 2 to get to 50, 10 to get to 60, so 12 to get to 60. So then this is like 13 over 24. So 2 and 13 over 24. That, honestly is, I don't know. I mean, I like math, but I didn't really enjoy that. Right? I mean, I'm kind of down for this stuff mostly, but I don't know, that wasn't great. So let's double back for a second. Let's sort of double back to where we were here. Let's kind of reset ourselves for a second. So this was 5 and 16 over 24 minus 3 and 3 over 24, right? I mean, that's the original, just converted so that our fractions have common denominators. When I do that conversion, I'm only converting the fraction parts, right? I'm not really messing with the 5 and the 3. I don't need to scale those up because they're just whole numbers, right? I'm only changing the way the fractions look. One of the things that I would hope you would sort of start to notice here, right, is if I did 5 minus 3, that would give me 2 as a whole number. If I just sort of set up and subtract the whole value minus the whole value, I get 2, which is what I had here, and then even better, 16 over 24 minus 3 over 24. What I'm going to do is I'm just going to sort of change this up just a little bit. Right, so then 16 minus 3 over 24, I mean, that's going to be 13 over 24, right? So without having to sort of jump everything up, if I essentially just do this subtraction by number type, if I do whole number minus whole number and sort of fraction minus fraction, it gets me without having to scale up into the hundreds and 75 and all this stuff and do this slightly longer arithmetic. It gets me to my answer much, much, much faster. There is a catch here. This sort of works very smoothly provided right, I have 16 versus 3 if I'm subtracting, and I have sort of a bigger minus a smaller number, then everything is fine. There's not really any big issue here. We'll sort of do some other examples to show you what happens if that doesn't go quite so smoothly. So the other option here, right, is rather than sort of convert into impropers, just sort of leave everything as a mixed number and just sort of subtract by type, right? 5 minus 3 is 2. 16 over 24 minus this 3 over 24. These mixed numbers, right? 5 and 16 over 24. This really means 5 plus 16 over 24, right? Minus. This is sort of really 3 plus 3 over 24. So, in some sense, what you're doing is almost doing a little bit of a distribution and just sort of a regrouping by type. The whole number sort of subtracted and the fractions subtracted, and then we sort of end up with this thing, and it saves us from having to scale all the way up to this sort of 136 and 75. So I kind of like that a little bit better. Honestly, that I think runs a little bit more smoothly. So that's kind of my suggestion. Let's just do another sort of short example, maybe. And I'll probably just stick with the mixed number form, and I'll try to illustrate, maybe just sort of talk at what would happen if we did a conversion. Let's do, I don't know, just an addition one, I guess. That was a subtraction. How about 9 and 3/8? We just did eighths. What should we do instead? And then let's do plus 4 and 1/6 or something, right? So we'll do our LCD here off to the side. LCD 4, 6, and 8. These guys have some overlap, right? 2 and 3. You can kind of anticipate. This is 12, kind of 18. 24, if we start to think ahead, 8, 16, 24, we're going to hit 24 and 24 pretty quick. This would be 6 times 4. So we'll do that one times 4 and 4 would be 8 times 3. So then our values here, so this is 9 and 9 over 24 plus 4 and 4 over 24. Just a coincidence, of course, that these whole numbers in these numerators are matching up. That was just a total fluke with these particular numbers. So again, my suggestion here, rather than convert these into true impropers, right, don't do 9 times 24 plus 9, right? Don't do 4 times 24 plus 4. I don't know what those numbers are going to be. I'd like to just not do that. So let's skip it. Let's just sort of group these by type. 9 plus 4, and then our fractions, right? 9 over 24 plus 4 over 24. Everything's just adding together here. So 9 and 4 is going to be 13. 9 and 4 up top is also going to be 13. But then that's over 24. No reductions to do here. We just sort of get our final answer pretty quickly and without a whole lot of fuss. I'm going to do one last video to show you a little bit what could sort of, quote unquote, go wrong. If we do get some numbers where we get addition values where we have slightly bigger numbers, or if we subtract and we just have a smaller and a bigger number that aren't really lined up so well. I'd like to show you how to deal with that. You can sort of do a carrying or a borrowing thing, like you sort of would do in sort of very sort of old school arithmetic, sort of stacked addition and subtraction. So we'll do that in one last video for this section.